pass 1, we will get the input source program will be taken as the input. Location counter will be there. Machine operation table, pseudo operation table, symbol table, literal table. All these things will be there. Now we know that here MOT is already filled, POT is filled, it won't be updated. Location counter will point to the start address of the program. Literal table, symbol table, these tables will be initialized in the pass 1. Later it may be filled with additional values that is derived in pass 2 also. Now last is a copy of the input to be used by pass 2. So we have seen in the illustration that initially if there is a pseudo opcode's instruction can be carried out. If there is a machine opcode can be replaced with the actual binary code of the machine opcode. So such things will be done, and those portion that portion of the program will be given as input for pass 2. Now in pass 2, this source program given as the prepared by pass 1 will be given to pass 2 as an input. Location counter will be given as such MOT, POT, ST, and there is BT also. So these tables will be used in pass 2 to generate the target code. So these things are often queried in the question papers also, to identify the data structures used in either passes or in different passes also. So we have to know what are the data required in these two passes. Now we will discuss about the pass 1 of the assembly process. See, this is the flowchart. We will discuss the entire thing. And it's a minimized view of what is happening in reality. There are a lot of parallel processing goes on in the assembly process. So we'll take a minimized view of the entire construction phase of symbol table. So we can see that initially the source code will be read statement by statement. Now, before we read the once we read the statement, the first statement, then we will get the location counter value of the program also from start 0. Say 0 is a starting value. Similarly, when we get that, LC value will be properly initialized. Once LC value is initialized, every instruction will be having an opcode field. Then what is the opcode? Is the opcode is a pseudo opcode? If it is a pseudo opcode, how it can check that? For that purpose, port is there, pseudo opcode table. Port will be searched with a pseudo opcode given in the user's program. If there is a match between the code and what is in the pseudo opcode, that means it's a correct pseudo opcode. Then the corresponding action corresponding to the given pseudo opcode will be retrieved and that will be executed. There is a special opcode pseudo opcode called as end, which is to be given as the end of the program. And if the end of the program is met, then that means that entire pass 1 is over, then pass 2 will have to be executed. Now suppose that if the given code is not a pseudo opcode, in that case it will check whether it is a machine opcode or not. How it is being checked? To check that the given value of the machine opcode will be searched in the MOT table. If it is not there, if it is present in the MOT, then the details regarding each machine opcode will be searched. That means the binary code of the machine opcode, its length, instruction format, all these things will be retrieved by assembler and it will be used for the later part of processing. Now, if the operand field contains a literal value, then the literal will have to be processed. If the literal is present in the literal table, then nothing is to be done. That means some literals can be repetitively used. We know that variables, constants, literals, they can be used, they can, same thing can occur multiple times. So if already it is added in the literal table, nothing is to be done. Otherwise, details are to be added in the literal table. If the label field is the label field of the instruction will be also checked. See, in assembly language statement, there is a clear format for an assembly language statement. There has to be a place where the load, the name of the program says John, it should be appeared. After that, what is where the start will be there. After start, what should be there? Similarly, where the labels will be kept, where the letters will be kept. So for everything, there is a field in the statement. So corresponding field will be checked by the assembler. And if a label presence is present in the source code, that label will be added to the symbol table if it is not added before. So this is the sequence that goes on. Then the next statement will be taken care. So instructions will be taken line by line. Literals will be processed. Pseudo opcode will be if the opcode is a pseudo opcode, POT will be searched, looked up. If the POT is end, that means entire pass 1 is over, it can go to pass 2. Now if the pseudo opcode is not end, then corresponding actions will be taken up and the next statement will be read. If the opcode is of machine opcode, then from mode the required values will be retrieved corresponding to a machine opcode and that will be processed. Then the next line will be read. Now suppose that if the machine opcode is found, in that case, details regarding each machine code, that is length of the code, will be retrieved from the mode and it will be processed. And here you can see an else part. In the else part, you can see that error messages will be flashed. And that is also the job of an assembler. Assembler will not keep the programmer in dark if some error happens. What is the kind of error that occurred? It can be a misspelled machine opcode. It can be a non-matching statement where either an opcode is missing or where an opcode is not expected, an operand is given. So such things can come in the program. Those things will be flashed to the programmer and it will go back to the next statement. So statement by statement, entire statements will be processed like this. Then once the end pseudocode is met, pass 2 is taken up. So that this is the entire pass 1 of the assembly process. Now we'll go to pass 2. In pass 2, the actual code will be generated. See, again here, each statement will be read. And this time, our source code will not be referred. The intermediate output generated in pass 1 will be referred. So read a statement from the output of pass 1. Then its machine opcode will be checked again. If it is a pseudo opcode, then type of pseudo opcode will be checked. If the end statement is end pseudo opcode is met, that means entire code generation is over, then the process will be terminated. Otherwise, it is a valid pseudo opcode that has for which some valid actions are to be taken. Those actions will be retrieved by the assembler and those things will be done. After that, LC value will be properly updated. Then the next statement will be taken up. Suppose that it is not a pseudo opcode. In that case, the given opcode will be searched in the MOT. If an entry is found in the MOT, then the details from the MOT will be retrieved again. Length, type, and the binary code of MOT, the machine opcode will be retrieved, and this retrieved information will be used in the machine opcode. Also, it evaluates the operand field of the machine opcode, and some data will be already there in a symbol table, a literal table related to an opcode. Even that will be taken care, and then assembler will assemble together all these informations, and the complete binary equivalent of the instructions will be created. Then the LC will be again updated, location counter, so that it can point to the next instruction. So this loop will continue till the n pseudo opcode is entered. Once the n pseudo opcode is entered, compiler assembler would have generated the final target code, or if there were any fatal errors, any kind of errors where the entire assembly process could not be done meaningfully, in that case, errors will be displayed to the programmer so that he can go back to source code assembly program, make necessary corrections, and recompile that. This is how pass 1 and pass 2 of the assembly process goes on.